Welcome to Learning Module Week 6b. We're going to talk about the impact of quality on our purchase cost, our cost of goods sold, say, depending on quality, the impact of quality. So it's a common practice in purchasing today to have buyers not purely incentivized by piece price. And it used to be more that buyers were incentivized more by piece price in the view of how they performed their jobs. Of course, nothing is ever black and white in the world, and it isn't like buyers didn't care or whatever, they're bad people or, myopic. But incentives in the organization sometimes drove buyers, and still does sometimes, to just think about cost and to overemphasize and have a bias for cost over other criteria when they purchase things. There's a big trend in the sourcing world to look at total cost, total landed cost, and to consider all sorts of important implications that drive, related costs out of that source decision, such as quality, such as support during engineering phases of the product, the ability of a supplier to generate technical innovations, the ability of the supplier to have capacity and build on time, do things at the right time, to provide people to work with our teams and integrate with us. So there's a variety, right? And you see it a lot of times, cost, quality, and delivery is the big stacks. But whatever nuance makes sense for us to value, buyers are becoming more and more cognizant and integrating those nuances into their sourcing decisions. In this example, we're just going to look at the impact of quality on the costing decision. Okay, so let's take a look. Come on forward here, puppy dog. Okay, so in this example, we have the impact of quality at Springfield Hospital. They have 2 dialysis machines. Both have a special valve that's normally replaced every 2 weeks when the machine is idle. As a result, Springfield uses about 50 valves per year. The hospital has 2 alternative sources for the valves. The purchase price and the quality for those suppliers are fairly well known, and they're as shown in the chart. Supplier A is expensive. On a piece price basis, they're $10 per valve. Supplier B is 20% of that cost, $2 per valve. The reliability, the percent good out of these valves, is 99.8%, which is 2 failures per 1,000 for the supplier A. And supplier B at 95%, that's 1 failure in 20. So it's a very high failure rate. So we've got a big discrepancy in the piece price, and we got a big discrepancy in the quality level of what we're buying. Let's see if through this example we can see how that might be analyzed and made sense of it. So remember, we're talking about dialysis, right? So this is expensive equipment. We've got people who are really life and death. When you need dialysis, you need dialysis. You're hopefully not at the point where you're actually going to fail, or your life's going to fail when you get it, but it is still nonetheless a life and death matter for people that need it. It's highly scheduled. These assets are highly utilized because they are expensive. So interruption is painful for the patient. It's painful for the hospital. It means asset utilization goes down and customer satisfaction goes down, possible medical emergencies, and lost capacity. So the estimated cost of a failed valve is $1,000 per incident, right? Failure outside of this regular maintenance twice a month, where there is no failure, that's preventive maintenance, right? This is a cost of the emergency maintenance, $1,000 per incident. So we can model that very simply and look at our annual costs. Okay, so we're going to buy 50 of these units because they get replaced every 2 weeks, and there's 2 machines, so 25 times a year, that's close enough. And valves, right? So if we buy 50 valves times $10, our direct material cost is going to be $500. versus if we buy 50 for $2, we're going to spend $100. Failure cost, 0.02% of all valves, or 2 in 1,000, right? Times those 50 valves would only be so many per year, right? 0.02 per year, 2% per year would be the 1,000 times that ratio would give us $100. Okay. On the other hand, if we're losing 1 in 20, we would have 2.5 failures per year, which would be $2,500 in failure costs. So the very expensive failure event is weighing in here. So this example shows an extreme where we have a very inexpensive product at very different prices for that inexpensive product, one many times the other, but a very different quality for that inexpensive product. And how important it is in this case to understand that buying the cheaper product, right, and spending what we think is $100, and we think we're saving $400, that if we take a total cost and really understand the nuances and the full cost of ownership of this valve, that we see that there is no justification whatsoever in thinking we're saving money with a lower cost product, because we're actually driving cost into our organization. Okay, we can compare the 600 and the 2600 to see that. In summary, there's many costs in addition to piece costs that have to be considered, and depending on what business you're in and what drives cost into your organization, how you really get value out of what you're buying, and what happens when it fails or what happens when it's not delivered on time, etc., then you can start shaking out some of these other costs, right? So total cost sourcing is a common approach in industrial buying and business-to-business buying. It's very mature and well understood, and understanding cost is a big deal for professional buyers. Buyers need to be aware of all costs of a purchase decision, because really they are the representatives of the company's value acquisition there, and not just trying to drive down piece price. I hope you enjoyed this little brief summary of total cost and how an example of poor quality could drive hidden cost into a product. And that completes this section.